Record. Okay. All right. Number one. Yes. Printed it. Like this. Hopefully I have it in. So tell me, so I think one is Jester, right? And tell me if I'm right. Convert 52.3699, and this is in decimal degrees because there's a decimal point and then it's degrees, to okay. How do you want to do that? How did you do that? How would you want to do that? Would you want to do it in your calculator if you can?
Yeah.
So if you do it in your calculator, tell me what you get.
I got 52 degrees, 22 minutes, and 11.64 seconds.
You want me to tell you how? I'm going to leave it all the way out. When you're putting it in here, all you have to do is put in 52 decimal point 3699. You don't even have to hit the degrees. Just punched it in, and then do second angle, which is that second apse, and go down to number 4, which is degrees minutes a second, and hit enter. And it converts it for you. Long-handed, how would I do that? 52 is going to come straight down. On a test, I would say, especially we're going to be practicing more with this. So the 52 comes straight down. Then you do 36.99 times 60, because there's 60 minutes in a degree. 60 seconds in a minute, 60 minutes in a degree. So we take 0.3699 times 60. That brings me down degrees. When I got that, I got 22.194. So then that will be 22 minutes. And then the remainder is 0.9. And you're going to multiply that by 60, and that'll give you your seconds. When I do that, I give 52 degrees. That's the answer. That's the answer. First way is a lot easier. I want you to make sure, even if you don't have the calculator I have, if you have one that you need help with, because we're going to be doing a lot of conversions to be able to work our calculations. So we're going back and forth. Because when you're doing trig, you have to have it in decimal degrees. If we're going to do our are our latitude and departure corrections, which will be later on in our chapter. We have to have it in decimal degrees. So I want you to be able to be comfortable doing it in your calculator. Number 2 is (53 degrees, 20 minutes, 30 seconds to Ezekiel, that was yours. So what did you do it in your calculator?
No, I
Did it by hand?
divide, bring the 53 down.
And then this would give you
20 divided by 60.33.
So we really need to do the 30 divided by 60 first, right? Let me put it in my calculator. So I do in my calculator, I'm going to do 53, and I'm going to do second angle, which is degrees, is number 1. 20 minutes, that's second apps, the second one. And remember, the seconds are over here. It's that alpha, the plus button. 30 alpha plus. And if you hit enter, it'll automatically put it in the decimal degrees. And then it's 8888 remaining. Kind of goes all the way out. So that's if I do it straight in the calculator. If we're going to do it by hand, 30, 20, 30. So you want to divide this by 60 first. So that would give me 0.5. Bring the 0.5 into, that would be 20.5. Bring the 20 straight down. And then we're going to divide this by 60. So 20.5 divided by 60. I write something down wrong.
I got 53.241666.
That's what it should be. In here,
Right.
so I punched something in wrong. That's what it should be. So again, 53 second angle degrees, 20 second angle minutes, 30 alpha. Yep. So it doesn't hurt, maybe test-wise, to double check. I knew something was wrong because it didn't. Okay. So now if I take the 20.5 and divide that by your 60, there's where you got 53 decimal 341666. Same thing. Long, short, same answer. Riley, read number 3 and tell me what you got.
If I remember correctly, it says that G and SS stands for Ground Navigation Satellite Systems.
Mm-hmm.
And I put false, that stands for Global Communication Satellite Systems.
So have you seen that on one other test before? Global, because we can use Russian satellites, Chinese are going to orbit those. So for the U.S. military, we have 31 satellites that are orbiting the Earth. So probably half are on the back side that we can't. And we've got to be locked on to 4. So we'll start learning about that when we do the GIS and GNSS. So we have like handheld units we carry out. And I'll get you to originally go in, get all the light poles in the parking lot. And then we'll bring it in and you can download and put it in Google Earth and it'll put the light poles in there for you. It's pretty cool. So it's real quick and easy. It's not math. We're making pretty maps and collecting our own data. So we got some new units, so I got to start practicing with those. So we ordered 4 new ones because they get outdated pretty quick. They're 5 years old and already outdated, so I got 4 new ones. So that would be false. Number 4 is Wyatt, so let me put it up. So it's SFT, that's US survey feet, because the SFT was beside the 8. 2 meters. And make sure I've got, is it the number right? Because,
You're on the wrong one. Yeah.
okay, that's what,
Number 4.
oh, I was on number 5. No. So, 6, 3, 2. And I can say, I'm going to save these documents. I want it SFT, and I want it just feet, which is international. So what should I use in our textbook? What should I use maybe to do number 4?
US survey foot, here equals
So page 23. So I would use page 23. So under that, I'm going to write the one for survey feet first. So the survey feet one, 1 foot. One under the standard, the foot is 1 SFT is equal to 0.3008006 meters. So there's the conversion for the US survey. So that was the one that was in 1893. Then in 59, they came up with the international foot. So I'm given meters and I want survey feet. So I'm going to write down here. What am I looking for? Survey feet. So my survey feet needs to be on top. And the meters need to be on the bottom. So what you're solving for when you do 1 foot equals so-and-so, because our meters are canceling, you'll be left with. So take that number and divide it by and tell me what you get.
2075, 427.
You've got what?
2075, 427.10. 2075, 427.109.
109. Anybody else? Is that what you got, Wyatt?
Yeah.
So that's SFT. Okay, so we're going to drop down and do the next one. So again, we're solving for feet. Meters are cancel and we'll be left with feet. So what did you have for that one?
2075.154.
All right, I'm going to go ahead and stay on this page because now we're going to be working survey feet to meters, and my conversions are still up here. So 5, these are Landon's. That's it. So again, this is my conversion up here. 1 survey feet equals 0.3048006 meters. So this time I want to know meters. So meters go on top. So just knowing what they're asking for lets you know when you do your conversion which one goes on top. Okay, Landon, what'd you get for A? 153. 153.88. Uh-huh. 0.969 meters. Okay. Second one. 11. 1188. 876. 0.876. Like that right there. Meters.
I got 0.88.
88. 88. It'd round up to 88. So we're not asking for significant figures or digits. So if it's a test, I'll know how you round it. I'm not going to be counting off. You kept it to 1 or 2, not specifically. Page 3. So that was 6, right? No, that was 5. So 6 is converting meters to US survey. So we're given meters. My handwriting's really bad here. Six, 8, 6. And B. Okay. So my conversion for this is 1 foot equals 0.3048 meters. So I'm wanting the answer in US survey feet, wrong one. I just assumed. Okay. So I'm wanting it in US survey feet. So the 1 goes on top. All right, Tony, what'd you get for A?
I got divided by 0.34806.
Mm-hmm.
I got 2, 2, 4, 5.
2, 2, 4, 5.
It's a lot of numbers after that.
Is it a decimal?
Yeah,
Okay, give me 3.
7436. So that's 7434.
Okay. And that would be SFT. Do I get a second? What'd you get?
5.2, you got 4.5.
Hey, do your own question.
4.5 is 5.2.
5, 2.
0.305.
Anybody else?
I got
Riley, did you get that?
the 5 2.
5, 2. Okay.
What you got?
2,252. 305.
Sometimes punching it in twice.
Can I look at 5B for a second?
5B.
Wrong.
Yeah. Did I write it down wrong?
I got, it might be wrong, but I got 1,180.872.
3874. David, what'd you get?
That's what you had. I gave you the wrong answer.
I got 1180.
3874. Here's my calculator. 1180.
1180.
Yeah, I must have either heard you wrong.
That was me. I gave you the wrong answer. I'll be quiet.
That's all right. A 7. I got 876. Yes. Oh, I did it wrong too. I don't know what I just did. 1180. There you go. Does that look better? All right, going back to this one. Do I got a check on the A?
Yes, ma'am.
Okay. How about Tony? What'd you get for B?
18649.
What do you got?
18649.
18649.
0348.
2 what?
0348.
I got a second on that.
Check on the first one again.
Yes, sir.
Check on the first one again.
Yeah.
Okay. 686.504 divided by 0.3048. I got the right conversion in there. I got what they got for the first one.
That's 365 or 305.
305.
It's 2,252.305. Second one, 5684.2. Second one, I got 18,649.3048.
You got 0.30?
Yeah, you have it.
I got
No, 0.03. I just changed my numbers around. The older I get, the more dyslexic I get. I'll look at it and read it backwards. All right, so I'm gonna do 7 and then we'll take our break. So 7's gonna be Chris. Seven, we want, if it's meters, we want US survey feet. And that's SFT. I want SFT. So that's still my conversion here, so that works out. So, oh, my paper's touching the board. Where are my paper touches? So we want our answer in meters. We're given that. We're solving for meters. So if I'm solving for meters, the meters is going to go on top. So in real life scenario, we'll always have reference sheets. For conversions. You're going to do more conversions in surveying than you would be engineering. Because surveying, we're usually using old deeds that are usually in chains and links. So we're learning. So I come across that every day. I was showing them an old survey that Mr. Bevel had, which teaches the associates in engineering and electronics. He had it in his corners were to old, his corners were old like trees, like an oak tree. His distances were in chains and links. His bearings I don't even know if he had bearings, but it was a survey that went with his deed. So in the survey law class, I was showing that, some examples of old conversions that we're using. So what'd you get for A, Chris?
For A, I got 2,854.41.
2,854 point what?
41.
41. And that's meters. And second one?
1465.17.
1465.
.17.
Okay, so that's, I don't need to put 1,465 point what?
17.
17. Do I got a check on that? Check.
Yep.
Everybody, okay. All right, so take a break. 8 goes to,
I had 8 now.
okay. Y'all go ahead and get a break. I think it's page 24 that I'm gonna get the notes off of.
You won't be able to get 5 feet on that. Back in the day, that's how we used to hunt.
Believe me, your time. Last day, last summer.
Why Chief didn't have a chance back then.
Okay, so let's-
Yes, sir.
So again, if you need to be in that CPR 115 class in the spring, we need to get you in there and get you in the CED 111. You only have classes on Monday and Wednesday.
What's the last class? You said 1 to 8. What's the?
That's the statics,
That's called.
which will be Mr. B.
Okay, I only need 2 classes because they did all
4 hours a piece, but
3 would be, one is 3, one's 4, and the static is 5.
Oh, I didn't know you couldn't use a Civ login instead of the computer.
You should be able to.
I logged in with it, and he came over to me and he was like, what login did you use? And I was just like, we have like a Civ one for civil engineering upstairs. And he was like, okay. And then he came back like 2 minutes later and was like, you gotta log out of that. Because it's just for upstairs only. They probably thought I was trying to hack into there.
So can you go and use it down here at the end of the
They said it's just, they said they didn't lock it for upstairs, so
Okay.
you. they were
I
just like-
use it on a different, I use it over in Cumberland Hall.
Well, I don't know. He just like, I was downstairs in the computer lab and he was like, well, they didn't lock it for upstairs, that's why you can log in. But I was like, cause I have just a regular one. And he was like, yeah, just log into that. I don't know what
But the
difference.
thing is, that's the point of us having a bigger login for your CAD files, and we don't want you to have to do
Well, I was
CAD files.
curious
at
if they
home.
had, I figured they didn't have like AutoCAD down there. I was just like.
They have it on 1 or 2.
Yeah, I was
that's it.
just curious, so I went and logged into it, I didn't see it, and then it came over.
What happened was last spring when we got sent home,
Mhm.
if people didn't have CAD, the
Yeah.
lab was never shut down. The lab was open the whole 16 weeks. So we moved some of the computers from upstairs downstairs
Okay.
to have the ArcGIS and to have the CAD on there, because I had, people, we used CAD in the spring,
Yeah,
and architecture needed CAD for some of their students, so we moved them downstairs and never moved them back.
Would it still be like that if you get shut down this year?
What?
That people would still go down there and use AutoCAD if we get put online again?
I don't think we will. I really don't think we will be put online, it may be just for a short time. I think we will, because we see now that it's working, you see there, and I told y'all wrong, there was 25 students that had tested positive since the spring, since the fall, but 4 were online and 1 never came to campus, so only 20. And then they didn't affect anybody else, so I think if we still keep up with our protocols, we can keep things up. Even though when you get your book for we try not to use textbooks, but, the CEG, I did order a book, but it wasn't a very expensive book, but it gave you all the free stuff, it gave you all the software. So you would have the GIS software at home, you have the class, but you actually have it where you work on it at home. Whereas in before, we couldn't. Is that what's looking on my screen?
it happens, it comes and then it goes.
Wow,
I have no idea why it happens.
pixel, it means like somebody else.
Enough Wi-Fi?
So I did, the book was like less than $100, I think, and so I ordered one for the GIS just for you to have software at home, and then we have a textbook. It's because I actually, when I took a completely all online GIS class, that was the textbook we used, and I go back to it several times. If there's something I need to do, so I'm actually revamping that whole class, because I wouldn't have had a textbook. And then the second thing is we got new GIS equipment, so I'm gonna have to revamp my spring class, but I'm hoping it'll be, all face to face, but we still would cap it at 12, maybe 14. And that doesn't, and I'm not saying these classes are gonna fill up right now, but come December, and you have people from other colleges coming back, and it seems like they do, then they're gonna jump into the classes that don't have a prereq. Meaning that GIS and that EGR has no prereq, so people are so it fills up pretty quick. And I want you guys to get in the class first. I think we got you in it and Tony in it, but if you want me to put you in it, just write your student ID number and phone number, and I'll print an eval and put you in it, and then I'll give it to you next class. So it'll just be Monday, Wednesday. Even if you want to take a math and you decide you want to take the math in the spring, we can do it in the morning on Monday and Wednesday. And you don't have to come at all, even on Friday. So Tuesday, Thursday, and Friday would be completely open for you guys. You still get a break, kind of like a lunch break. I don't think if I had to, the reason I did that is because I didn't know who was going to teach the statics last year. We weren't sure from the year, we weren't sure because we had an associates in engineering instructor start and resign all in 2 months. And then it left it open, and then Mr. had to teach it. He taught it under duress, statics for my class, so he said he wouldn't teach it again. And then now that Mr. D or Jaime's here, we probably might go back to the daytime, but since if I was gonna have to get somebody into industry to teach it, then I needed to set it for after, the later at night to get somebody to come over to teach it. So I asked the students, would you want me just to stack your classes right before it, and then you come, get your classes and go, and then leave your Tuesday, Thursday, and Friday open? So that's how it came. So probably next year I'll go back to probably putting it the day, but right now it didn't seem like that many people, most of them I think kind of liked it. So like this fall right now, the students only have Monday and Wednesday classes as well. For my second year guys only have Monday and Wednesday. So they're all Tuesday, Thursday, and Friday because they've got their math out of the way. And spring's a little more, but so I try to group them together where you're not coming and going, but still give you enough of a break to get you something to eat. And like I said, we'll keep motivated or you're not, when in my CEG class, you're going to be doing something you're not going to have time to, you're going to be doing, I'll be doing stuff and you're going to be following me and we're going to collect data, so you're not going to fall asleep in that class. You have plenty to do. It's going to be kind of like CAD, but I'm going to do instructor-led ones, mostly with you, with the book. And then we're going to collect our own data and we're going to make our own maps. So really no tests, just, oh yeah, I need to talk to y'all about tests. Everybody back in here? All but Landon. So like for my survey, the Survey 110 class. Anybody look at the syllabi? I don't want to accidentally knock myself out of it. Just want to show you. Not everybody's a good test taker. Some are, some aren't. So basically, your 6 tests are only weighted 25%. So one or two bad tests is not going to hurt you. Now, if I would have weighted those some, I know we had physics class, the tests were weighted 60%. Final was 20, and then our homework was 10, and then our labs were 10. So all the tests, not everybody's a good test taker, so I'm not going to put all of my weight in my test grades. So as you can see, I kind of split it up where it's not killing you if you don't test good. If you get a 0 on one, whatever the lowest, whatever your lowest, you do your final and your final's 80, then I'll come back and replace that lowest test grade with your final. But it is not going to kill you. I should have all A's and B's in here. Shouldn't be a reason why, if you're not a good test taker, you could be a good hands-on person, but I should have all A's and B's in here. So I do that, but when we go to do the GIS class, since I'm not doing a lot of tests, we're doing more hands-on, so all the labs that we do, like 16 labs will be weighted like 40% of your grade, but each one's not, you do not want one item more than 25%. So my final exam is 25%, but you don't want one item worth more than that. I try to kind of spread it out to where you're not something's not your best suit, you still can. All right, so, so we're doing number 8, A and B. I put the two conversions at the top, page 24. There's 66 feet in a chain, and there's 100 links in a chain. So technically, you really should have taken the 12 divided by 100, because we want to put them in. We want to convert the links to chains first. But I'll tell you how I do it. So then that gives me 6.12 chains. So 6 chains and 12 links. And that's, I'm crossing through the links. It's really, if you just divide 12 by 100 and then add that back to your 6. Now, our conversion, let me move that up a little bit. That's chains. And there's 66 feet in one chain. So what did you get for that?
403.92.
1203.
No, 403.
403. 403.92 feet. Okay, so the second one, if you would have put in 24, this needs to be 0.8. You need that placeholder of 8 links, because 8 divided by 100 is 0.08. What did you get for that one?
1589. 1589.
1589.
0.28.
Who did I give 9 to? Jester? Did I give you A, B, and C? Yeah, I gave you all 3, didn't I? Okay. So I put the conversions up top for this one. So in the front of the book, 1 acre equals 43,560 square feet. So if we're given square feet, and I want the answer in acres, I'm going to write it here. And the answer's in acres, so 1 acre goes on top. What did you get for A?
2.19807.
2.198. Okay, that's acres. Okay. So now I want it in hectaacres. Again, the front of the book. 1 hectare equals 2.471 acres. So I'm gonna go ahead and bring my acres straight down to this one, since I already know it. And I want it in hectaacres, so the 1 hectare goes on top. What did you get for that?
0.8895.
And they call that HA for hectare. So 1 square, so it wants it in square Gunther chain. 1 acre is 10 chains square. So we've got acres up top, right? So I'm going to bring that acres right here. And they want it in chains square, so I'm going to put 10. And what did you get for that one?
21.9807.
Chains. So that's an easy one. So 1 acre is 10 chains square. So we just had to take our acres and multiply it by 10, and that gives us our chain square. So actually, when we're doing, when they did surveying, it wasn't part of what the meets and bounds, it was mostly out west and up north. They were set out in sections. So 1 mile by 1 mile was actually, 1 mile is actually 80 chains. So if I would have did my conversion from 80, I do 80 times 66, 5,280. So they would set it out in chains. So they would did 80 by 80, which is 1 mile squared. And then they worked it out where that'd be exactly 640 acres. And then they would do this northeast, southeast, southwest, northwest. So if they did 640 acres, then that would break down to 160 acres per block. So we kind of use this same scenario. So when things were granted, because we came over from North Carolina was from England. Some of the Spanish, like Florida Spanish, some of those did it in the meets and bounds, depending on where we originally started setting up. They just told the settlers, we're going to give you land, just state claim the land, put you some corners there, and we're going to deed you that. We want to get as many, Spaniards here, or as many English here. So North Carolina, South Carolina, I think Georgia, know for sure meets and bounds. And then a lot of the others are what they call townships and sections, which are based off chains. All right, 10.
I have a question about number 9.
Okay.
For A.
Mhm. All right, the wrong.
Should be 95,748 divided by 1 acre instead.
Well, we're wanting the answer in acres. So to get the answer in acres, so this is your conversion. Do you agree 1 acre equals 43,560? Right here, top front of the book. Okay, so so that's the 2 numbers we're dealing with. Whatever you're solving for is the number that goes on top. And we want this answer in acres. So acres went on top, so you divide it by it. So did you not get that answer?
Well, no, I only get the answer that you have. If multiplied to 95,000 by 1 acre. It's the other way around, I believe.
You should divide the 95,748, divide that by 43,560, 2.19.
Yeah, you have the way you have it there, you have 45,560 divided by 95. 43. It should be reversed, right? If you have 1 acre of that,
Mm-hmm. So, yeah. So if you take this divided by 43,560, you should get that.
because all I'm doing is I'm just doing 95,748 divided by 4,000 or 43,560.
Correct.
That's it.
That's how you get the answer.
So what is the 1 acre on top?
That's what the conversion is. 1 acre equals 43,560. So in other words, you're not assuming the zero place. That one, that's the conversion. 1 acre equals that. So you're solving for the 1 acre. But if you would, it's the same thing essentially what you're doing. If you don't do this, then you don't actually get your acres. You're just taking this divided by this, and you don't see how it converts to acres.
So I'm just doing it a different way.
Yeah, you're just doing it a different way, but you're not seeing how the acres, because the feet cancel and you're left with the acres, but really you're just taking that number divided by that, which is what you were doing. But if you don't put the 1 acre, then you're not getting the answer in acres. So I'm doing it the long way. Good. So 10, probably I gave A and B. Who was that? Ezekiel, was that you? You had 9, right, Jester?
Yes.
So 10 would be,
Yes.
so my conversion, so I want to go ahead and I'm going to bring down, make a little more room. So I want to do 1 divided by 4. That gives me 0.25, correct? So that would be 8.25 divided by 12. And then we want to add it back to the 22. We get house plans. Those house plans are usually in inches, and that's like 8.5 inches, 8.25. So I've got to convert that over to feet so I can put it in. Typically, I'd convert them over to feet so I can put them in CAD to do my site plan. Not so much as house plans that y'all are working on in the CAD class. Second one, so that would have been your answer for that one. Second, we're going to do the same thing, 1 divided by 4. Add it back to the 6. Did I write it down wrong? Well, it's supposed to be 1/2, it is. So that'd be 0.5. What'd you get? So I know that 6 inches is 0.5. I know 7 inches is 0.58. I know 8 inches is 0.66666. I know 9 is 0.75. I know 10 is 0.83333. I know 11 is 0.92. And I know a half inch is 0.04. Quarter inch is 0.02. So just doing that time and time and time and time and time again, I've got them down pat. I don't even have to use the calculator. 11. Compute the area of a rectangular lot in acres. So I want acres. I'll have to go to the next page. All right, so do I want to just go ahead and figure my area in meters squared? And then convert it over. So who had 11? Okay, so how did you do for A?
For meters, that's times them together and divided by 1/2. And
Okay.
then I did,
So what did you get when you got, so it's 1/2. If it was a rectangle, what would your formula be? Just based on height, if it was a rectangle, but this was a triangle, 1/2 based on height. So what'd you get in your meter squared for that?
I got 31154.9586.
Okay, so I need that in acres. So 1 acre equals 4,046.9. So I'm looking at the front of the book. So 1 acre for a So I'm looking for acres. So you're just going to divide that now. So what did you get?
7.698.
I'm going to write it up here. 7.698 acres. B was 3 chains, 16 links, and 4 chains, 59 links. How'd you solve that one?
I changed the length and changed the chains and then changed it to survey feet.
So here's my thought. If we have 1 acre is 10 chains squared. We could have done it. You said you converted this to, you times it by 66. And then it's 1/2. 'cause this. So what did you get your answer? It'd been square feet.
I didn't do the 1/2. I just did,
Is it a triangle? Yeah, it's a triangle, so you'd have to do 1/2 based on height. So I was just trying to put it all in one formula. You did 3.16 times 66. So you didn't, you just converted it and then did your area. Is that what you're saying?
Just went out probably, but I've done,
So what, you have 200 and something right here?
I got 280.
8.56. $302?
Yep.
Okay, so to get the area of a triangle, multiply those two. Did you have 31? Eight, three. So what you had? Or did you skip on to the next step?
Yes, ma'am.
And then last step is to put that in acres.
Yes, ma'am.
Oh man, I did have that one in. So what did you get for your answer?
1725.
Anybody else solve it that way, or did you solve it a different way?
Something like 8. Wow.
So I was trying to say if I did 3.16 times 4.59,
They're already changed.
and then divide by 2, then, so what I did is I just took my triangle, I'm gonna sketch it real quick. So this was 6. Okay. Okay, so it gave me that. And then remember, so I didn't even change it to feet. I'm gonna go straight from here to acres, and that would be 10 chain square is 1 acre. Okay, I want my answer in acres. These will cancel. So I'm going to get exactly what Riley had, but mine's going to be out. So I just did this one step. So I kind of condensed this down because I knew 10 chain squares equals 1 acre. If I'm solving for acres, then actually you're just going to divide what the area of the triangle is. Either way, whatever you're comfortable with. All right. 12 A and B. Thanks, Wyatt. What are the radians and degree minutes and seconds? Radians and degrees. Okay, so how many grads are in one revolution or 360 degrees?
400.
Okay. So how would you solve this one? What's the easiest way to solve this one?
About 63 by 400.
And that would put it in what, degrees, minutes, and seconds? Because that'd be,
Revolutions.
which would be the same thing as 360 degrees. $63.
360 degrees over one revolution will cancel out revolution.
You did 63,09,84 grads. 400? That's one revolution. Or what do I need to do next?
360 over one revolution. Cancel out revolution.
That's a revolution. And there is 360, we're solving for degrees, right? So you multiplied it by 360. And I got 56.78856 degrees decimal. But if I want to put it in degrees, minutes, and seconds, did you have 56 degrees, 47 minutes, 18.816 seconds? Can I convert that to radians?
Times pi over 180.
Yeah. Pi divided by 180. I'm doing that in the calculator. And I got for that one. I'll move this down. 0.991 radians. Yes, no, maybe?
Yes.
Okay. Do the same thing with B. Got 10 minutes to get, so 235, 8760 grads. We want to divide it by 400. Now leave me with one, actually that's one revolution. What'd you get for that? For when you took 235.876 divided by 400, 0.58. We want to multiply that by 360 degrees. And go ahead and convert it to decimal degrees in your calculator. So what would your answer, what's your answer in degrees, minutes, and seconds for B?
It's 212 degrees, 17 minutes, and 18.24 seconds.
212 degrees, 17
Minutes
mhm,
and 18.24 seconds.
So I got to check. Okay. And then to convert that to radians, it's pi over 180. And what'd you get for radians?
3.70.
0.370. 3.7. Okay. 3.7. Not good? Okay. All right, 13. A, I'm gonna put A here. So okay. So A and B were landed, right? So what'd you get when you add, just leaving it the roll number, what did you get? 255. 8824. 844. 8144.
That's it.
Okay. All right. So we want to look at the rightmost number in all of these. 5, 6, 4, 8. Which number is the leftmost? The 4. So your answer would be 255.8. That should have been your answer. Okay. Okay. 235 minus 917. 225. And it's not. 225.3. Okay. So which number in the two numbers is the rightmost? 7 and the 5. So which one's the leftmost out of those two? 5. So your answer should have been 225. So that's how you do subtraction or addition, and that's if you're working with significant figures. All right.
276.75.
Okay, so you got 276.75 times 9,337. What'd you get for your answer? 9 what?
9326.475.
Okay. So this is going to be by your, so how many significant figures are in the first number? The 2000 or 276.75. How many significant figures do you have there? 5. How many do you have in 33.7? 3. So your answer should be to 3. 1, 2, 3. So your answer should have been 93.
I think it's, all right.
So multiplication and division are not by the decimal place. They're by how many significant figures are in the original numbers. So D would be the same factor.
I got it for that, if you call that, 479.1.
This is my division. Yeah, let me do it like this. So 4, 9,
479.1.
and you divide that by the 10.29. And what was your answer all the way out?
Well, all the way out to 479.132, 167.
479 point,
132,
mm-hmm.
167, 152.
How many significant figures? 6. How many? 4. Answer should be to 4. 479.1 would be your answer. Last 14. A, B, I'm going to square that. So these need to be in the correct significant figures and powers of 10. So if I want A in powers of 10,
3.635.
so I'm moving it 1, 2 decimal places, 3.6325 times 10 to the second. So you always want to move your decimal place all the way as far left as you can to the one, there's only one number left. So 3.6. So if I'm doing this one, 1, 2, 3. Now, should I write it 1.2 times 10 to the third, or should it be if they give you 1200 and they give you the 2 zeros, then you're to assume that they're all significant. If they gave you 1.2 times 10 to the third, then you knew that only 2 were significant. So it really should be the second, the 1.200 times 10 to the third, because we have to assume they're all significant. Those can be kind of tricky. How about squaring 363, so this one's you, David, and then we're finishing up. I got 2 minutes.
Yeah, it's, when I started, I come up with 131,950.5625.
Okay,
And my answer was 1.3195 to the times 10 to the 5th power.
okay, so that's your number. We've got 5 significant figures, so 123.5. So that would, if I'm going ahead and put it into the significant figures, 1, 2, 3, no, it'd be 5, sorry. The 5 would be the last one, correct?
Yes.
So this would be,
Times 10 to the 5th power.
and so my 0 is actually over here. 1, 2, 3, 4, 5. Ten to the 5th?
Yes, ma'am.
So our answer would be 1, 2, 3, 4, 5. And then I would have to, so that would be the last number I show, and then we'd be 1, 2, 3, 4, 5. All right. Adding all 3 of these, what did you get?
I got 230.845.
And I'm gonna just leave that in because we're gonna divide it by, because it says wait and do them all, everything at the end. So that actually, because 3 is gonna be the smallest significant. So if you say 2.3.845 divided by 10.6, what do you get?
I got 2, I did it wrong. Because I didn't do 2 significant figures instead of 3.
Okay, so let's do 230.845 divided by 10.6.
Yeah, I got 21.777,83019.
Okay. Okay, so I just need it to 3, because that's got, this one really would only be, if I would have rounded it, it would actually been 5, but this is smaller. So the third one, 3, that's got 5, that's got 6, but if I'd have counted out.
2.18.
So my answer would be 2.18. Now I need it to the significant figures, or meant to powers of 10. 2.18, because the 7 we round out. And we're moving it 1 decimal place, so it'd be 2.18 times 10 to the 1. All right, good? I'm going to save and exit, so this is going to be test review.
Said the test we're gonna have formula sheet.
You always have. In every everything in surveying, you're gonna have formula sheets or your book, because in real life, that's how it is. So this is chapter test. Did anybody make 100, or they think they make 100?
I missed one.
You missed one.
The 11D, I forgot. I have. So instead of that 0.7, like 1.4.
So I'm saving this. It should come in as a PDF, and I'll email it to everybody.